My greetings. I am Farhan Rahman and I'll be introducing our EC assignment on the topic phasors and sinusoids. This topic comprises of some basic mathematical operations and some basic physical concepts like general wave equation and so on. So in my group, I was allotted question 1 to 6 and the rest will be illustrated by my group mates. So the first question that they have asked us is here. Given the sinusoidal voltage Vt equal to 50 cos 30t plus 10 degree volts, find the amplitude Vm, the time period, the frequency and Vt at t equal to 10 milliseconds. So in the first question they have asked us about the amplitude of the wave equation, and as we know that Vm is equal to cos omega t plus 5. So Vm here is 50 volts. As in the question they have mentioned that Vt equal to 50 cos 30t plus 10 degree. Now for the time period, as we know that t is equal to 2 pi by omega and omega over here is 30, as we can see that 50 cos omega t, where omega is 30 in this question. So we'll put 30 in our expression t equal to 2 pi by omega, which will give us 0.2094 seconds or 209.4 milliseconds. So for the frequency we have the formula f equal to omega by 2 pi. Here as we know that omega is 30, so on putting the value of omega in the formula, we get 30 by 2 pi, which is equal to 4.775 hertz. And for the D part, they have given or mentioned in the question that t equal to 10 milliseconds. So we'll put the value of t equal to 10 milliseconds in our Vt equation, and we'll get that V of 0.01 seconds equal to 50 cos 30 into 0.01 radian plus 10 degree. Here first we have to convert the radian into angles. So as we know that one radian equal to 180 degree, pi radian equal to 180 degree. So 1 radian will be equal to pi by 180 and 0.01 radian will be equal to 1.72 degrees plus 10 degree. So our final answer will be 4.48 volts and where omega t equal to 0.3 radian. Now for the second question, which is very similar to the first question, the second question is a current source in a linear circuit has Is equal to 15 cos 25 pi t plus 25 degree amperes. What is the amplitude of the current? What is the angular frequency? Find the frequency of the current. Calculate Is at t equal to 2 milliseconds. So for the first part, we have amplitude equal to 15 amperes. As we know that I equal to Im cos omega t plus 5. So our Im over here is 15 amps. For the second part, that is the angular frequency, we have omega which is equal to 25 into pi. As we can see in the general equation that Is equal to 15 cos 25t, where 25 is our omega. And for the frequency we have the formula that f equal to omega by 2 pi, and on putting the value we get the answer as 12.5 hertz. What is the frequency of the current? For the frequency, we know that f is equals to omega by 2 pi. So putting the value of omega 30, we get the answer putting the value of omega as 25 pi, we get the answer as 12.5 hertz. Now for calculating the value of Is at t equal to 2 milliseconds, we'll substitute the value of t as 2 milliseconds in the general equation, that is Is equal to 15 into 15 25 pi t plus 25 degree. So we'll get 15 cos 25 into 2 into 10 to the power minus 3 plus 25 degrees. Here also we have to convert the angle which is in radians into degrees. So converting the angle, that is 25 pi into 2 into 10 to the power minus 3 into degrees, we get 1.157. So the value of current is 13.577 amps. In the third question, we need to have a general mathematical knowledge of sine angle conversions, that is sine theta equal to cos 90 plus theta. So in the A part, basically the question is express the following functions in cosine form. The A part is 10 sine omega t plus 30, B is minus 9 sine 8t, C is minus 20 sine omega t plus 45. The first part is 10 sine omega t plus 30, and as we know that sine 90 plus theta equal to cos theta. So 10 cos omega t plus 30 minus 90 equal to 10 cos omega t minus 60. So this is our converted angle. The B part is minus 9 sine 8t. We'll do the same thing as we did in the previous part, where we'll convert the angle sine theta as cos 90 plus theta. So our answer is 9 cos 8t plus 90. For the C part, we have minus 20 sine omega t plus 45. Here also we'll do the same thing as we did for the previous two parts. Here we'll do sine theta equal to cos 90 plus theta. So we'll get 20 cos omega t plus 45 plus 90, which therefore is equal to 20 cos omega t plus 135. For the fourth question, we have to convert express v equal to 8 cos 70 plus 15 in the sine form, and b part is convert I equal to minus 10 sine 3t minus 85 to cosine form. So the first part is a equal to 8 cos 70 plus 15, and as we know that cos 90 plus theta equal to sine theta, so we get the answer as 8 sine 70 plus 15 plus 90, which is equal to 8 sine 70 plus 105 degrees. For the P part, we have I as minus 10 sine 3t minus 85. So by applying the formula that sine 90 plus theta equal to cos theta, we get 10 cos 3t minus 85 plus 90, and therefore the answer is 10 cos 3t plus 5 degree. For the fifth question, it's given that V1 equal to 45 sine omega t plus 30 and V2 equal to 5 cos omega t minus 30. We have to determine the phase angle between the two sinusoids and which one lags the other. So for the first equation, we have V1 as 45 sine omega t plus 30, and by applying the mathematical operation that sine theta equal to cos 90 plus theta, we get 45 cos omega t plus 30 minus 90 degrees, which therefore is equal to 45 cos omega t minus 60. Now we have V2 as 50 cos omega t minus 30. Now this is already in the cosine form, so we don't need to convert it to sine form. So this will indicate like this, as we know that the angle 60 is phi 1, which is the phase angle for the first equation, and 30 degree is the phase angle for the second equation. And to calculate the phase difference, we have to calculate delta phi 1 minus phi 2. So on doing the operation delta phi 1 minus phi 2, we get 30 degree. So this indicates that the phase angle between the two signals is 30 degree, and that V1 lags V2 by a phase angle of 30 degree. The sixth question is, for the following pairs of sinusoids, determine which one leads and by how much. We have the A part as Vt equal to 10 cos 4t minus 60 and It equal to 4 sin 4t plus 50. B is V1t equal to 4 cos 377 plus 10 and V2 is minus 20 cos 377. And for the C part, xt equal to 13 cos 2t plus 5 sin 2t and yt equal to 15 cos 2t minus 11.8 degrees. So first what we need to look out is that all the equations, like all the parameters, should be in one single waveform. That is, if a first equation is in sine, then the other should be also in sine, so that we can calculate the phase angle between them. So our first equation here is Vt is equal to 10 cos 4t minus 60 and It equal to 4 sin 4t plus 50. So we have to convert the equation It in the form of cosine. So we get that 4 sin 4t plus 50 equal to 4 cos 4t plus 50 minus 90 degrees, which is equal to 4 cos 4t minus 40 degrees. So now, as we have observed in the fifth question, that the phase angle for first equation is phi1, which is equal to 60 degree, and the phase angle for the second equation is phi2, which is equal to 40 degree. Then calculating the difference between these two phi1 and phi2, we get 20 degree. So the as we can see that I2 leads VT by a phase angle of 20 degree. Now moving on to the B part, we have V1t equal to 4 cos 377t plus 10 degree, and V2 is also given in the cosine, so there is no need to convert into sine. The only thing that we need to look out is to convert this minus 20 into plus 20, which can be done by 20 cos 377 plus 180 degree. As we know that cos theta plus pi equal to minus cos theta. So now we can see that phi1 is equal to 10 degrees and phi2 equal to 180 degrees, and we can also see that phi2 minus phi1 is equal to 170 degree. So here the V2t leads V1t by a phase angle of 170 degree. And the last part of the question is xt equal to 13 cos 2t plus 5 sin 2t. Here we have to convert the sine expression into cos expression by doing that by calculating sine theta equal to cos 90 plus theta cos theta plus 90, we get 5 cos 2t minus 90. And after that, we have to convert this into the polar form, which will give x equal to 13 angle 0 plus 5 angle 90, which is equal to 13 minus 5j. Here we have converted the polar form into the rectangular form, and then after that we have converted the rectangular into the polar form. So now we have xt equal to 13.928 cos 2t minus 21.404 degree, and yt as 15 cos 2t minus 11.8. For the first equation, xt equal to 13.928 cos 2t minus 21.04, we have phi1 equal to 21.04. And for the second equation, we have phi2 as 11.18. So now on considering the phase difference as 11.18 degree plus 21.04, we have 9.24. Thus yt leads xt by a phase difference of 9.